Hi, welcome to Zona Mechanica. There is an MCQ on deflection of beams. Figure at the margin indicates the weightage of the question, that is 2 marks. A force P is applied at a distance x from the end of the beam as shown in the figure. What would be the value of x so that the displacement at A is equal to 0? Well, there are 4 options given. See, this is the frame or beam. Okay, this is a U-shaped beam starting from here up to this point. Okay, and it has 3 limbs. Okay, these 2 limbs are of length L. Okay, and a point load P is acting at x distance from this end. Okay, and this is the point A. Okay, the load is single point load, but it has 2 effects at this point A. First one, this due to this direct loading, it will create a deflection over here downward. Okay, let this is delta 1. Okay, and another effect will be due to moment developed by this force. Since this force is acting away from this point, okay, it has some distance over here, so this force into this distance will give the magnitude of the moment, and this moment is clearly anti-clockwise moment, right? So this moment will create a deflection upward, right? Upward. So the question is, what would be the value of x so that the displacement at A is equal to 0? See, the displacement to be 0, the delta 1 and delta 2 are to be equal in magnitude, right? This is downward deflection and this is upward deflection. Okay, that means delta 1 is equal to delta 2. Okay, so let us calculate the delta 1 and delta 2. See, the first one, for delta 1, this force will get transferred through this beam and it will act over here, right? We can assume this force over here, okay, acting as a point load at the end point of a cantilever beam of length L. Okay, simply suppose there is a cantilever beam of length L and there is a point load acting over here. Okay, so this is the case, first one. So what would be the deflection? Delta 1 is equal to P into L cube by 3 EI, right? This is a standard result, we know. And the second one, see the second one, the moment. Okay, see this P into this distance, this is L minus X, right? This distance, so P into L minus X, this is the anti-clockwise moment, and this moment will act over here, right? So the second one, we can assume that there is a cantilever beam of length L and the moment is acting like this, okay, M, which is equal to P into L minus X. Okay, okay, so it will create a deflection upward which will be equal to M into L square by 2 EI, right? This is one more standard result. Okay, so by the question, the deflection at the point A, overall deflection will be 0. That means delta 1 will be equal to delta 2. Okay, that means PL cube 3 EI is equal to M L square by 2 EI. Okay, So that is, see this L square and L cube, so P into L by 3 EI will go, so M is P into L minus X, okay, by 2. So again P will go, right? So L by 3 is equal to L minus X by 2. So which implies 2 into L is equal to 3 into L minus 3 into X. So which implies 3X is equal to L, that is X is equal to 1 by 3L, that is 0.33 L, right? So clearly the value of X is coming 0.33 L. It's matching with option C. So option C is the correct answer. Hope you have understood. If you are enjoying, please do share with your friends. If you are new to my channel, please do subscribe it.